In this video, we will study chloroform and its properties. Chloroform and its properties. The formula of chloroform is CHCl3. It is also known as trichlromethane. Here, method of preparation. First preparation from ethanol and bleaching powder. Bleaching powder in water. So step 1 is the reaction of bleaching powder with water. This is called hydrolysis. What do you mean by hydrolysis? Hydrolysis means when a water is added to a salt, so this is a salt, to give rise to either acidic or basic solution. So here is a calcium oxide part which will react with water to form calcium hydroxide, and chlorine will be formed. So calcium hydroxide is base and chlorine is an acidic gas. Second step will be oxidation of ethanol. So here ethanol has formula CH3CH2. We will write in this way, OH plus Cl2. So this is the oxidation reaction where chlorine is acting as an oxidizing agent. Oxidizing agent to form CH3 CHO plus 2HCl. This compound is acetaldehyde or ethanol. This compound is acetaldehyde or ethanol. Step 2. Chlorine, because chlorine is a mild oxidizing agent, it can cause the oxidation of alcohol into aldehyde. So next step will be chlorination. Next step will be chlorination. So CH3 CHO plus Cl2. This CH3, 3 hydrogen atom will get substituted by chlorine. So we will take 3Cl2 to form CCl3CHO plus 3HCl. This is called chloral or trichloroacetaldehyde. Chloral or trichloroacetaldehyde. Then step 4 will be, so in these all, both the compounds will be used, calcium hydroxide as well as chlorine. Chlorine is in causing oxidation in first step, and second step is the chlorination, because no oxidation possibility is in second step, because chlorine is a mild oxidizing agent. It can cause the oxidation of alcohol into aldehyde or ketone, not into carboxylic acid. Now we will take chloral, and chloral we will write double bond O, CH and CCl3. Calcium hydroxide we will write in this way, HO, Ca, OH plus CCl3, CHO. Now, these are the two molecules of chloroform getting removed. Two molecules of chloroform are removed. Two molecules of CHCl3 plus C. Ca, Ca, O, then O, then we will write in this way, O double bond CH, O Ca, O single bond C double bond. So this is one HC00 and this is another HC00. In this way we have HC00 whole twice Ca, which is known as calcium formate. Now next will be from acetone and bleaching powder and water. So bleaching powder will react with water. This is hydrolysis, right? This is hydrolysis. So CaO and water will combine to form CaOH whole twice plus 2HCl. Second, that first step will be, because we are taking acetone, and acetone is already oxidized form of alcohol. It doesn't have that hydrogen at carbon atom, so it cannot be oxidized by chlorine. As we know that chlorine is mild oxidizing agent. Mild oxidizing agent. Mild means it causes very slow oxidation. Weak oxidizing agent we can say. So it will cause chlorination only. Oxidation cannot be caused. So here chlorination will be caused by chlorine. So 3Cl2, only one of the CH3 will get chlorinated. CH3, C double bond O, CCl3 plus 3HCl molecule. This is called trichloroacetone. Then step 2 will be, this trichloroacetone is treated with calcium hydroxide. Need to prepare chloroform. We need to prepare chloroform, so we will write calcium hydroxide as open bond. Right side first will be written CCl3, then C double bond O, then CH3. Left side we will write CCl3 on the side of hydrogen. CCl3, C double bond O and CH3, to give rise to one molecule from this side, another one molecule from this side, to give two molecules of CHCl3 plus, now C, CH3, C double bond O, then O, then Ca, then O, then C double bond O, CH3. So this is the right side of CH3C double O, and this is the left side of CH3C double O. In condensed form, it will be written as CH3C double O whole twice Ca, giving rise to two molecules of chloroform and one molecule of calcium acetate. One molecule of calcium acetate. Now we are coming to the next method of preparation, number 3, from CCl4. So CCl4 on reduction in presence of Fe and water gives rise to CHCl3 plus 2HCl molecule. This is the third equation. Fourth reaction will be from chloral hydrate. Chloral hydrate. So chloral hydrate is CCl3CHO dot H2O. This is chloral hydrate. It is treated with NaOH to form one molecule of CHCl3, one molecule of CHCl3 So this becomes CHCl3 plus this is CHO. So it will be converted into HCOONA. So this carbon is getting oxidized plus water. In this way, chloroform is prepared. So 2, 1, 3, 1, 4 hydrogen, 1, 1, 2, 2, 4 hydrogen. In this way, we prepare chloroform. Now we are coming to the properties of chloroform. Physical properties. First, we will go for physical properties. Number 1, it is colorless liquid with sweet smell and taste. Liquid state is because of dipole-dipole interaction. The liquid state of CHCl3 is because of what? Dipole-dipole interaction. There is no possibility of hydrogen bonding, because for hydrogen bonding, molecule must have your OH bond, NH bond, or HF. So there is no this condition. So that's why it is just a liquid because of dipole-dipole interaction, right? Second, because it is organic compound, so it is insoluble in water. It is insoluble in water. Most of the organic compounds do not dissolve in water, and those organic compounds will get dissolved in water, which either get ionized like acids or those which form intermolecular hydrogen bonding with water. Next point, very important note to remember, that chloroform is an anaesthetic substance. This is an anaesthetic substance. Anaesthetic substance. Anaesthetic substance means causing unconsciousness. We can say in normally that unconsciousness, it causes unconsciousness, and unconsciousness may be permanent if high dose of chloroform is inhaled. So it causes what? Unconsciousness, and may cause death, because if inhaled in high dose. Why will it cause death? Why will it cause death? The reason, because on air oxidation in presence of sunlight, it forms phosgene COCl2, phosgene gas, which is highly toxic. So unconsciousness is that caused by the chloroform, but this may become fatal. It is toxic because it causes death, and death is because of this COCl2, and COCl2, as get dissolved in blood, the carbon monoxide part of the this chloroform, the phosgene gas combines with the blood to form permanent complex with the hemoglobin. That is called carbamine hemoglobin. Now, next point, its vapors burn with green flame. With green flame. So these 2 points are very important for chloroform in physical property, that it causes unconsciousness and high dose of it can cause death because of phosgene gas. And this one, vapors of chloroform burn with green flame. Now we are coming to chemical properties of chloroform. Number 1, when exposed to sunlight and air, it undergoes oxidation to form phosgene gas, that is CHCl3 plus O2 in presence of sunlight. So this is the part of air. Oxygen is the part of air which causes the oxidation of this chloroform to form COCl2. So that means half water molecule, that oxygen molecule, that is one atom. Half O2 means one O. Because this we take in molecular form because it is the part of air. It is not nascent oxygen, but we can think that it is one atom of oxygen to form and 2 HCl molecule. So this is phosgene, and which is toxic and it causes death. Next will be very important note to remember for chloroform, that it is kept in dark colored bottle, and bottle is filled up to brim. Up to brim. Why to fill up to brim? Why to fill up to brim? Why to fill up to brim? You took a bottle of containing chloroform. This must be filled till the brim, till the knot, and the bottle should be of dark color. And second point, so that air should not be there. Here, if it is completely filled, then no air will be present, and the bottle is dark colored, so sunlight will not reach, so that it should not undergo air oxidation to form highly toxic phosgene gas. This point is very important for the exam point of view. This is dark colored bottle. This is the dark colored bottle, and it is completely filled, because air oxidation causes, once again I am writing the equation for the air oxidation of it. So CHCl3 plus half O2 in presence of sunlight to form CoCl2 plus 2HCl. This is not 2HCl, this is 1HCl. So this is your phosgene gas which makes the chloroform toxic. Now, one more thing is added. Ethanol or ethyl alcohol 1 to 2% ethanol is added. Why to add ethanol? Why to add ethanol? Reason, because ethanol neutralizes the poisoning effect caused by phosgene gas. The phosgene gas will be neutralized by ethanol. This equation is asked. Reason is asked that phosgene gas makes the chloroform toxic and it will only be formed when bottle is not filled up to brim and it is kept in air, that in presence of sunlight, and if the bottle is not dark colored, then sunlight will enter the chloroform where air will cause the oxidation of chloroform to form this gas, phosgene gas CoCl2. Suppose if it is formed, if some part of sunlight reaches the chloroform, somehow reaches the chloroform, if there is ethanol present, that causes the neutralization of phosgene. So C2H5OH plus CoCl2, this is CO. Anyhow, if it is converted into CO3, is it possible? Definitely it is possible. 2 C2H5OH. It will form C2H5 whole twice. C2H5 whole twice, because C2H5O, C2H5, 2 C2H5, so C2H5 whole twice. Now this O, 2 O atoms, and this CO will form CO3 plus 2 HCl molecule will be formed. So this is now this is CO3, ethyl carbonate. So this your chloroform, that phosgene gas is neutralized by ethanol and it should be 1 to 2%. Right? So it should be stored in dark colored bottle and bottle should be filled up to brim so that its air oxidation should not take place and phosgene gas should not get formed. If it is formed, anyhow it is formed, then we will have to add 1 to 2% just ethanol, that will cause neutralization of this phosgene into diethyl carbonate. Now next chemical property will be your hydrolysis of chloroform. Hydrolysis of chloroform. And hydrolysis will be basic hydrolysis. CHCl3 plus KOH. This is basic hydrolysis. So we will take 3 KOH molecule because we have to substitute 3 Cl to form HCOH, OH minus 3 KCl. So this is aqueous KOH. And 3 OH cannot be present on same carbon. So it is unstable compound. So removal of one water molecule will take place to form HCOOH plus water. This formic acid is formed. But this formic acid will again combine with KOH, which is a strong base present in this mixture, and this is an axis. So it will form HCOOH K plus H2O, that is potassium formate. This is the end product of hydrolysis of chloroform. Number 3. Third chemical property of chloroform is your nitration. And nitration will be done in your with concentrated HNO3. So we are taking here chloroform HC, Cl, Cl and Cl plus HNO3, we will write HONO2. This is concentrated HNO3. To form to form your CCl3 NO2. Very important point. Plus water. This CCl3 NO2 is your chloropicrin. What is it called? What is it called? Chloropicrin. And this chloropicrin is used as CCl3 NO2 is chloropicrin. It is used as insecticide and was used as war gas in Second World War. Right? And you might have heard that Hitler, German. Next is your reaction of chloroform with acetone in presence of alcoholic KOH. This reaction will take place in presence of alcoholic KOH to form. So acetone is CH3, C, CH3, double bond O, plus we will write as HCCl3. This CCl3 will attack on C of C double bond O group and O on H of CH. In this way, we will have CH3, C, CH3, double bond will get converted into single bond to form OH and CCl3. This is also an important reaction. This compound is called chloritone. Chloritone. It is a hypnotic substance. Hypnotic substance. That if somebody smells this compound, he or she will do same that you will see. Next, reduction of chloroform. Now we are coming to reduction of chloroform. Number 1, CHCl3 in presence of zinc and HCl, Zn and HCl to give CH2Cl2 plus HCl. This is called dichloromethane. Dichloromethane. Next will be reduction with zinc and water. Reduction with zinc and water. So CH Cl3 plus H2O. You may write H2O because Zn and H2O work combine together to form ZNO plus nascent hydrogen. So this is your steam. So this nascent hydrogen will be used in presence of zinc and water to form CH4. So 6 hydrogen. CH4 plus 3 HCl. So 3 hydrogen will be used to convert CH into CH4 and 3 hydrogen will take out chlorine in the form of 3 HCl. Now we are coming to last reaction. Very important reaction of chloroform. Carbyl amine reaction. This you will study in amines as well. This is also called isocyanide test and is used to test primary amines. Primary amines, whether they are aliphatic or aromatic. So here we will take CHCl3. Primary amines means RNH2 plus CHCl3. So 3Cl should get removed by 3 KOH, alcoholic KOH, to give 3 KCl to 3 KCl plus 3 H2O because 3 O are there. 3 H2O. The left parties are R, N and C. This is called alkyl isocyanide or alkyl carbyl amine. That's why the reaction is called carbyl amine. And this reaction, the product formed carbylamine, yeah, alkyl isocyanide, has offensive odor. And it is identified by offensive odor. That shows that this is the test for primary amine. So we will take example. Suppose CH3NH2, very important reaction. One is CH3NH2 we are taking. Second we are taking C2H5NH2, often asked in exams. And third we are taking C6H5NH2. So is in this reaction aliphatic and aromatic, both amines are taken. So this is aniline, which is aromatic, will be treated with CaCl3 because both are organic. So KH will be alcoholic, not aqueous. CaCl3 plus KOH, alcoholic, not aqueous. All are organic compound. So KOH will be alcoholic. Here 3 KOH, 3 KOH and 3 KOH to remove 3Cl to give rise to, and this will be done by heating the compound, heating the mixture. So 3 KCl, 3 H2O, 3 KCl, 3 H2O, 3 KCl and 3 H2. Remaining is CH3NC, CH3N or C, methyl isocyanide, C2H5, C2H5NC, ethyl isocyanide, C6H5NC, phenyl isocyanide with offensive odor. and is used to test the amines. Next reaction will be Reimer-Tiemann reaction. Reimer-Tiemann reaction of chloroform. So this is phenol. We are taking phenol plus CaCl3 plus NaOH aqueous. So two molecules of NaOH will be taken. So phenol and two molecules of NaOH along with the chloroform. So ClCsCl2 we will write. This is HCl. One hydrogen will be removed in the form of HCl and one hydrogen will be removed from H. This reaction will take place at 340 Kelvin to give rise to ONA. And one Na get attached with oxygen from sodium phenoxide, and CHCl2 will combine with this one. So here reaction intermediate is CHCl2 is the reaction intermediate of that Reimer-Tiemann reaction. What will be removed? See, one NaCl, and look at these two OH and these two H. So 2H2O will be removed. After that, two more aqueous NaOH will be taken to cause the substitution of these two chlorine. So here 2 NaCl will be removed to form ONA, CH, OH and OH. In place of two chlorine atoms, there will be two OH. And because two OH on the same carbon cannot remain on the same carbon, so it is unstable compound. This unstable compound will get decomposed to form CHO, O negative and A positive. One water molecule will be removed. After that, it is hydrolyzed by dilute HCl to give OH and CHO. This compound is named as 2-hydroxybenzaldehyde. 2-hydroxybenzaldehyde, or commonly it is called salicylaldehyde. This is all about the chloroform. We will study in the next video iodoform and H.